Here are exponential equations to solve. Question 35. Solve the following exponential equations. A. 3 to the power of 3x plus 1 equals to 27 times 9 to the power of x. And B is 2 to the power of 2x minus 2 to the power of x plus 1 minus 8 equals to 0. Okay, now first one, what do you think? How should we do it? Well, let's have the common bases. So the strategy here is to form common base. Do you see that? Now, common base, this is 3. We can write 27 as a power of 3 and 9 also as a power of 3, correct? So I can write this as 27 becomes 3 to the power of 3. 3 times 3 is 9. 9 times 3 is 27. And 9 as 3 squared, so it becomes 3 to the power of 2x, correct? Now that leads to 3 to the power of 3 plus 2x, correct? Now, if I compare these two equations, then my base is same, which is 3. So exponent should also be same, right? Therefore, I can equate 3x plus 1 equals to 3 plus 2x. These two exponents, right? These two should be same, correct? Now, let's solve for x. So we'll bring 2x here. So we have 3x minus 2x equals to 3 minus 1. So x equals to 3 minus 1 is 2. So that is the solution, correct? You can always check your solution. Plug in 2 here. So 9 times 2 is 81. So you get 81 times 27. Plug in 2 here. And you get 2 times 3 is 6. 6 plus 7, right? And then figure it out whether it's same or not. Correct. Now here, we have an exponential equation which is kind of a quadratic form. So we call it a quadratic form. How? Let us assume, so let's define a variable. Let 2 to the power of x equals to, let's say, a number n. In that case, I can write this equation as n square minus what? 2 to the power of x is n. So this is actually 2 to the power of x plus 1. So it becomes 2 times 2 to the power of x, right? So times n minus 8 equals 0. Well, what I did was, let me show you here. It was 2 to the power of x plus 1. So I wrote this as 2 to the power of x times 2 to the power of 1, correct? Which is 2 times 2 to the power of x, correct? And then I substituted n for 2 to the power of x. Do you see that relation? That's how I did this part. Now I have a quadratic equation in n, so I can find sum and product. So my product should be minus 8 and sum should be minus 2. So I have the numbers as minus 4 and plus 2, correct? Now from here, I can write n equals to 4 or n equals to minus 2. So these two should give me the solution of this equation, correct? So we have n equals to 4 and n equals to minus 2. We need to find what is x, correct? 2 to the power of x is n. Therefore, we have two solutions. We can write here as 2 to the power of x equals to 4 or 2 to the power of x equals to minus 2, correct? If I write 2 to the power of x as 4, I can make this as common base 2 square. Therefore, I get x equals to 2, right? Now, this is the other solution. How can I get 2 to the power of x as minus 2? Do I get, it cannot be negative 2, correct? So 2 to the power of x cannot be negative 2. Therefore, I have no solution for this. So I have only one solution, which is x equals to 2. Right? So that's my solution. You can always check this solution, right? How will you check it? You can substitute x here. So we have 2 times 2 is 4. So 2 to the power of 4 minus 2 plus 1 is 3 minus 8. Is it equals to 0 or not? So then you can figure out if it is so or not. So you can, if I write 2 here, so I get 2 to the power of 2 times 2 is 4, and then here it gives me 2 to the power of, if I write x as 2, 3 and minus 8, right? So what is 2 to the power of 4? 2 times 2 is 4, 4 times 2 8, 8 times 2 16, so I get 16, and here it's just minus 8 and minus 8. If I do that, I get 0. So it works perfectly fine. So that's the solution, right? So my solution is x is equal to 2. Is it okay? So that's how we solve our exponential equations, and at times you can see they could be in quadratic form. I hope you understand the process. The critical thing here was substitution. We substituted 2 to the power of x equals to n and then evaluated n, and from n we found the value of x. Okay? Thank you.